Lesson 6.3. Rewrite exponential as logarithmic functions. Alright, so what are logarithms? Logarithms are exponents. We call it log base b, that number there is the base of a. What it means is it's the exponent of b to get a. So in other words, it's b to the what equals a, and we're looking for that exponent. So logarithms equal exponents. Log base b of a equals the exponent of b. For example, let's try page 312, number 13. We're supposed to evaluate this log. So you're supposed to think, what exponent of 3 gives me 81? Well, we could try a few things, and we could say 3, I don't know, raised to the 3. Oh, no, that's 27. How about 3 raised to the 4 is 81? Look at that. 3 to the 4 is 81. So what do we get? This logarithm equals the exponent, 4. Why don't you try page 312, number 15? Log base 3 of 3. Pause while you do it. The answer is 1, because 3 to the first equals 3. Your calculator has 2 log buttons. There's one that's the common log, and it's just log. As you can see, it's kind of near the center top of my calculator right there. It says log. That's log base 10. Things like the Richter scale or decibels for the loudness of sound are log base 10. And pH. It's all log base 10. It's common log. The other is the LN button, which is there. It's a LN, stands for natural log. It is log base E. So the two on the calculator. Now a few calculators have a way to do any base. This one, for example, if I hit my toolbox, you can see that one there lets me put in any base. But really, you only need one button, you'll see. Anyway, so let's use the calculator. Page 312, number 23. Use the calculator to evaluate log of 6. Notice there's no base written. That means that it is base 10. So you're asking what power of 10 gives you 6? 10 to what number is 6? Well, I don't know. So we'll hit log 6. It's log base 10 of 6 equals, we'll want the decimal here, 0.778. Why don't you try number 25, ln, remember that's natural log of 1/3. Pause. Your answer should be negative 1.099. All right, so logarithms are exponents. They equal exponents. But here's the more formal definition. Log base b of y equals x. The symbol in the middle means it has the same relationship as b to the x equals y. So you can see b is the base in both of these. And you can see here x is the exponent. So x here is still the exponent. Remember, logarithms equal the exponents. And then we just have y as our other number. It's read as log base b of y equals x. Remember, it equals an exponent. Logarithms equal exponents. What they are, logs are useful because they are inverses with exponentials. They undo each other. They cancel out each other. Just like the square root of x squared, the square root and the square cancel out. Or multiplying by 2 and dividing by 2. Multiplying and dividing by the same thing cancels out. Well, log base 2 and 2 to the x, so this is the log, this is the exponential. They cancel out, leaving x. That's why they're useful. So let's try an example. Page 312, number 1. Rewrite this as an exponential. All right, so this is the base. Remember, logarithms equal exponents, so that's the exponent. And then the 9 is just what it equals. So it's 3 to the exponent equals 9. So remember, it's log base b of y equals x is the same thing as b to the x equals y. So the 3 was the b, the 2 was the x, which was the exponent, and the 9 was the y. So there we go. It's not a logarithm, it's now an exponential. Why don't you try this one? It's going the other way. It's currently an exponential. Rewrite it as a logarithm. I'll pause. All right, I'll work through this one. 6 is the base. The 2 is the exponent. So it's log the base of the number equals the exponent. So it's log of the base of the number equals the exponent. We can simplify some logarithmic expressions. If we have an exponential with base b and a logarithm with base b, inside each other they cancel. It's because they are inverses. Because they are inverses. For example, page 312, number 31. So notice we have 7, and then all the stuff on top is its exponent. So we have a logarithm and an exponent. And notice the bases are the same. Exponential and logarithm, if they have the same base, they cancel each other out, and we're left with x. Why don't you pause this and try page 312, number 35. This time we have an exponential. Inside of the logarithm and the exponential cancel out, leaving the 2x. So log base 3 and base 3 canceled, and the example base 7 and log base 7 canceled.